Find the remainder using long division. That's a G. Synthetic division, and you don't know it yet. Remainder theorem. So they're given this polynomial: 2x to the fourth plus 4x to the third minus x squared plus 0x plus 9. And then I put that in over x plus 1. Class x goes into 2x to the fourth.
2x cubed.
We multiply that, I get 2x to the fourth plus 2x to the third. Then I'm going to subtract. 2 minus 2 is 0. 4 minus 2 is?
2.
Bring it down, negative x squared. X divided by 2x to the third. 2x squared. So then I multiply. Two minus 2 is negative 1 minus 2. Negative 3, right? Class, do I need to bring down the 0x? Do I need it? How many times is x going? So let's just say you don't know what to do with the 0x. X divided by negative 3x squared, what happens? Negative 3x. Negative 3x times x. Negative 3x, yes? Negative 3x times x. Negative 3x times 1. Oh, I did need that 0x. You see that? So even if you don't know, just keep going and it kind of self-corrects. Math is so forgiving. Negative 3, opposite of negative 3 is plus 3, so negative 3 and a positive 3 is 0. 0 minus negative 3. Positive 3, right? Then I can use that 9. X goes into 3x. Three times x, 3x. 3 times 1 is 3. Subtract, our remainder is what? 6. Now, in the previous lesson, if I wanted to know what the answer is, the quotient, I would take 2x cubed plus 2x squared minus 3x plus 3. 6 here, is it positive or negative? So that's why it's plus 6. And then your divisor over x plus 1. So this would be the quotient, but kind of interesting. I asked a weird question. Did I ask for the quotient or the answer or to simplify?
No.
What did I ask for? The remainder. And I'm trying to lead us into today's lesson, but this kind of gives you an idea to review. Raise your hand if you got 6 as your remainder using long division. Put your 2 fingers on the parts that you can multiply to check your answer. Show your partner, give him a head nod. You should be able to multiply, well, this is how the remainder. So this, the divisor plus the quotient will equal the dividend. Does that make sense? Okay, let's do synthetic division now. This is yesterday's lesson. Class, what number do I put outside? Negative 1. Remember yesterday we learned to set that equal to 0. And then solve. So essentially x equals negative 1. We learned to write our coefficients. 2, 4, negative 1, 0, and 9. These numbers, what goes over here. 2, 4, negative 1, 0, 9. Class, what do I do? So what I got? What math operation now? Multiply diagonally. What do you get? What math operation? What do you get? Add. Multiply. Add. Multiply. Add. 6. So although the answer to my question about finding the remainder is 6, yesterday we learned about figuring out what each of these are. Klaus, what would you say this 2 represents? 1 less than what we started with, so that would be x. 2x cubed. What does this 2 represent? And just go back in descending order, down by the exponent. This will become what? This one? So x to the first, this is x to the 0, so that's just plus 3. And this would be plus 6 over x plus 1. Okay, here is today's lesson. So usually I kind of give you guys a formula, and then we kind of work out examples, right? But I'm just connecting it to just doing the math. I'm going to show you guys the remainder theorem and the factor theorem, okay? Now, the remainder theorem is very closely associated with what we've already done. Do you see what I highlighted here? Essentially what I'm going to do is I'm going to take negative 1. So now you know where I get this negative 1 from. And I'm just going to put it back into the function. So this is the function here. 2 times negative 1 to the 4th power plus 4 times negative 1 to the 3rd power, running out of space, negative 1 squared plus 9. Make it. So basically all I did is I take the negative 1 and I'm going to put it back into this function. And then we just use the order of operations to simplify. Negative 1 to the 4th power. Positive 1, yes? 1 times 2. Negative 1 to the 3rd power. Negative 1 times 4. Negative 1 squared. Opposite of 1. And then plus 9. And then we just add all of those together. 2 minus 4. Negative 2 minus 1. And negative 3 plus 9. Look at that. We got the same answer. Isn't math so wonderful? I found the remainder using all 3 variations. Okay, so how do I explain to you guys now, is it a factor, or this is called the factor theorem? Okay, let's do like a super easy division problem. Here's my question. Is 2 a factor of 3? Can I multiply 2 times something, a whole number, to equal 3? Why did you say no? You can use division to test it. Watch. 2 goes into 3. 2 goes into 3 how many times? And you multiply, what do you get? And you subtract, you get what? Okay, so this says I have a remainder. Yes? If you have a remainder, then it's not a factor. So the factor theorem basically says this. If it is a factor if your remainder is 0, but it's not a factor like this problem when the remainder is not equal to 0. So let's look at our problem. Class, do we have a remainder? Is the remainder equal to 0? No. Remainder is not equal to 0. So the answer is no. It is not a factor by the factor theorem. X plus 1 is not a factor. Why do we need to know this? Because eventually I'm going to say, find all the factors. You're like, where do I start? In tomorrow's lesson we use this rational roots theorem, but we can actually test them. X plus 1 is not a factor because if it was, it would be equal to 0.